Right. So today we're gonna talk about absorption. So let me have a look about slides here. Right. So in absorption, so what is absorption? So there are in many of unit operation there are the term of adsorption and also absorption. Yeah. In absorption, that means um, the the component or the solute is actually absorbed by the liquid. Usually the absorption, the other phase is the liquid. So for example, the gas or the solute is absorbed by the liquid, while in adsorption, adsorption ad, yeah, absorption, it is where the solute is actually just absorbed on the surface. Yeah, usually for adsorption, that is for the the solvent is it is actually like solid. Yeah, so the solid only just absorb on the surface. For example, adsorption of let's say the absorption of humidity, for example, that is also that is absorption. Okay. So what we're talking about here is absorption, which is we have maybe a stream of gases, and the gases maybe have something that we don't want, and the particular solute is to be absorbed by a liquid. Okay. So let's have a look on these examples. Right. Okay, so this is a typical absorption process. I took it from the Seder book. So we have a feed, then the feed contains water, would be a water vapor, and then air, and the air contains of argon, a little bit of argon, and then oxygen, and also nitrogen, and also acetone. Yeah, and then they have the acetone. So they have 10%, no, 10 divided by almost 6, yeah, 6 something, so it's quite a few acetone, yeah, maybe 0 point something percent. Okay, so the feed contains air, water vapor, and acetone vapor is a gas, and then the feed contains air, water vapor, and acetone, and then it is absorbed in the absorption column, and the gas leaving the absorption column will contain again still a little bit, we still have the water, nitrogen, argon, oxygen, but then we have a very small amount of acetone. Okay, so if you look at the mass balance here, the acetone from 10.3 kilomole per hour is absorbed, so the output is only 0.05. Okay, so this is the absorption process. Okay, and it is absorbed by a liquid absorbent, and the liquid absorbent is actually water. So the water will absorb the acetone, and then it will leaving the liquid, the exit liquid will have around 10.25 kilomole per hour acetone. Okay, so usually we in absorption we have the gas. Yeah, it's not a vapor. Okay, there are difference between gas and vapor, where in the vapor at around ambient condition it can be changed between vapor and liquid, while in gas around ambient temperature is only in a gas phase or in a vapor phase. Okay, so this is the around the gas phase. Okay, so and then also we have to select, ya, we have harus memilih. We have to select the which liquid absorbent that can absorb the component that we want to remove from the stream gas. Okay, in this case, water is actually good to remove acetone because both of them is polar solvent. Yeah, so the water can take that one there. Okay, and also we can also see the the pressure here. Yeah, there are the pressure, and then we can see there are different pressure in here, maybe because of there are some of the pressure drop, and here we also have the number of tray here. So it's actually for the absorption or distillation, it can be happening in tray column or in pack column. Okay, so in this case if they're using a tray column, but for our purposes, for our learning purposes, because we have learned about the tray column in the distillation, so for this absorption we're gonna learn it with pack column. Okay, and after the absorption about 2 weeks, we also have the another tugas, yeah, another assignments about pack column design. Right. Okay, let's have a look about the concept of gas absorption. Okay, and this is a concept as well. So for example, we have a natural gas with carbon dioxide about 8 to 14%. Okay, and then we want to liquefy, yeah, mencairkan. Okay, and because we have to liquefy the natural gas in a very low temperature, if it contains CO2, the CO2 will solidify first as a ice, yeah, as a dry ice, and then it's gonna block the pipeline. Okay, so we don't want that. So that means if we have a natural gas containing CO2, we have to reduce the CO2 maximum up to 200 ppm. In some places, sometimes it's only up to 50 ppm. Yeah? So it's very small. So 50 ppm, 50 divide 10 to the 6, let's say. So it's very small. Okay. So what would happen is the natural gas is actually contacted with the liquid, and the liquid loves the CO2 very much, right? So we'll try to find those liquid, and the suitable liquid is usually called amine liquid. So it contains the amine gugus amine, yeah, the amine group. For example, methyl ethyl amine, diethylamine, monodiethylamine, etc. Yeah. Okay. So if you check your HYSYS, there also an absorber package, yeah, in the thermodynamic model, and this also tell you the appropriate solution model for absorption. Okay, so with this absorption process, what happens is the CO2 in the natural gas will transfer into the amine liquid. So in the end, you will end up with the amine liquid that rich it with CO2, and then you're gonna leave out with a clean gas, where in the clean gas there's no CO2 or very small CO2 in that one, and then we can liquefy those natural gas. Okay, so so in gas liquid equilibrium, we have the gas, for example, the natural gas, and then the liquid, for example, the amine liquid, and the gas is actually gonna dissolve. Yeah, it's gonna dissolve, akan terlarut. Yeah, so it's gonna dissolve. Okay, and this is not gas, it's a vapor. The difference with distillation, which is vapor and liquid, is actually we have the vapor, and then it is a keseimbangan, yeah, equilibrium. But for the gas, it's actually the gas is absorbed as terlarut, yeah, like that one. Okay, so again, okay, so once you know about distillation, is actually you know the step-by-step process where you know the equilibrium and you also know about the operating line, yeah. And this also will apply to any unit operation, okay. So in any unit operation you will also have the equilibrium, and also you will have the operating line, okay. And again, in absorption we also need thermodynamic data, and the thermodynamic data is actually from it can be from thermodynamic data, or we can do forecasting, or but for new components, let's say we have some new components that hasn't been in the handbook, then maybe we have to do the experiment by itself, okay. And the absorption is actually divided into physical absorption and also chemical absorption. So in physical absorption, it will just dissolve, yeah, it will just dissolve, akan terlarut. But while in the solute or in the chemical absorption, it's just gonna react as a chemical absorption. Okay, the one that we're gonna discuss throughout the course is actually the physical absorption, yeah, absorptive physics. So we're not gonna talk about the reactive absorption or reactive distillation or the chemical absorption. We're just gonna talk about the physical absorption, okay. And in a physical absorption, we have the thermodynamic data. And the thermodynamic data that we're gonna use is called the gas solubility in liquid. Okay, think about Coca-Cola, yeah, Coke. Why Coca-Cola looks fresh if we put it in the fridge, for example, for a while? Have you ever tasted Coke? The first one is in the fridge for a while, and the second one, let's say you just put it in the room temperature, and then you open the cap, and then just wait maybe few hours, and then you try to taste it. Can you see the difference? Who likes Coke? Anyone?
Not healthy, Bu.
Yeah, not healthy. Right. Okay. Anyone tried? What is the difference between the Coke that we just took out from the fridge, and also just Coke that has been leave out for a few hours in the room temperature?
The one from the fridge feels more fizzier, Bu.
Feel what? Fresher?
Like fizzy, you know,
Oh,
yeah,
fizzy.
you
Yeah,
can feel the
okay.
bubbles.
Yeah. The fizziness actually based from the solubility of CO2. So when you have a cold Coca-Cola, you cold Coke, and then from the fridge, they have a higher solubility of carbon dioxide in the Coke. Okay, and then when you taste it, they just gonna vaporize or something, and then they gonna let our tongue like feel the fizziness, right? Okay, lebih apa, nyerang ya in Indonesia ya, okay. But if you leave out the Coke for a while, few hours, and then you drink it, what did you taste? Only water, and then a syrup, and then very very sweet maybe, yeah, okay. So yeah, because that is because at room temperature, that means that the solubility of CO2 is actually gonna decrease. So most of the CO2 is actually just gonna leaving the Coke, okay. So, and then you just end up with just water, sugar, and also just the taste, yeah, Coca-Cola taste something, okay. So that is very simple of physical absorption, yeah. So in the physical absorption, how CO2 is absorbed by the water, that's why in the advertisement apa, lebih baik diminum dingin gitu ya, they tell you that just put it in the fridge, because at that time I have a bottle here. So at that time, that the CO2 around the this is around 88 ya, not the coke, yeah. But anyway, for example, this one here, the CO2 on the right air around here is gonna be absorbed by the coke if it's in the fridge, okay. But however, if it is hot, then it's just gonna leave out, okay. That's also how we gonna use that one, information when we design the absorption column. Usually absorption column would be more favorable in low temperature and also at high pressure, because if you have high pressure of gas in here, they just gonna have quite high concentration here, and then it's gonna be easier for them to dissolve in the liquid. Okay, it's gonna be easier for them to dissolve in the liquid. While but the next things, okay, so if I go back here, so what is the next? Okay, so once you get the exit liquid there, it contains acetone. Of course you want to release the acetone into somewhere safely, right? And then you want to also recycle the liquid into, so we can use again, okay, the absorbent. So then we're gonna have another column, is it called desorption, okay. In the desorption column, you will have sometimes we put swing, we swing the composition, or the operating condition, for example, to make it higher pressure, higher temperature or lower pressure. So the dissolved gas will be released into the gas phase at that time. Okay, so yeah, this that's why usually there's one unit operation, if you know, it's called PSA. It can be pressure wing absorber or a pressure wing adsorber. For example, the group, ya, the research group in TRK, ya, Teknik Reaksi Kimia, Profesor Subagio, Bu Melia, and the team, during the pandemic, they're now making PSA or pressure swing adsorption. So how to absorb or to absorb, yeah, to absorb oxygen from the air and then concentrate it and then leave it out, a concentrated oxygen at the other chamber, right? So at that time, during when the pandemic was very in the peak one, and we need oxygen a lot, yeah, and then that would be one of the alternative solution. All right, now so back to here. So the gas solubility in liquid, if we increase the pressure and also lower the temperature, the solubility is also increasing. Okay, for example, in the Coke, if we for example, for the Coke here, if you have a lower temperature, it is like Kevin said, it's like the fizziness is there, or that means actually the solubility of the gas is also increased. Okay, and then we also have the number of solute in the liquid. It's called the molar concentration, and we called it CI, or concentration I in mole, or if it is written in fraction, so the number of fraction of solute in the liquid is called XI, right? Okay, and then for this number solute in the gas, from the partial pressure or tekanan parsial, we call it PI, and also in mole fraction is called YI. Okay. So to sum up again about the physical absorption and also the chemical absorption. So physical absorption is actually when there is no significant chemical reaction occur between absorbent and solute. For example, the absorption using water, like the acetone using water, or using hydrocarbon oil. So usually if we have a polar component, then it can be absorbed by a polar component as well. But if you have a non-polar solute, it can be absorbed by the hydrocarbon oil, for example. Okay, but chemical absorption or reactive absorption is actually the absorption where it accompanied by rapid and irreversible neutralization reaction in the liquid phase, and the process is irreversible. Okay, for example, the process for absorbing CO2 and H2S from aqueous solution, MAA, and the ethanol amine, for example. Okay, so here sometimes, so we can make it here, for example, so the acetone with the absorption of water, acrylonitrile, ammonia, ethanol, yeah, it can be absorbed by water, and the typical absorption is a physical. Okay, and for benzene, butadiene, butane, propane in hydrocarbon oil, so this is also easily vaporized, yeah, in the gas phase. It's called physical. Okay, another one, for example, reaction between hydrochloric vapor with aqueous sodium hydroxide, for example, or carbon dioxide with aqueous sodium hydroxide. This is called the irreversible chemical because it is a reaction, yeah, asam basa, yeah, and then the product, of course, irreversible. But here, sorry, this one, it can be reversible or irreversible, yeah. And then, for example, chlorine and water is actually reversible chemical. CO2 and H2S with MEADA is a reversible chemical. So we can actually make it vaporize it again in other desorption column if we change the operating condition. Okay, and then this one also, nitrogen oxide with water, is actually reversible chemicals. Right? Okay, so now let's have a look about the graph that tell you about the equilibrium data for absorption. Okay, we're gonna use a Henry's law, hukum Henry, and then the Henry's law usually only yeah, it can be happening on low concentration. Okay, so for example, the concentration of acetone, of the concentration of CO2, it, of course, it won't be like 90% CO2, right? Of course, you just can't use that. So because the mole fraction in the partial pressure usually only very small, maybe 0.1% or 2%, 3%. So sometimes we only use this region, hukum Henry, ya, and then it's only for a dilute concentration, hanya untuk konsentrasi rendah. Okay, and the correlation between the pressure and also the mole fraction of the solute in the liquid is called Henry's law, and it's actually equal to Pi equal to the Henry coefficient and multiply with Xi, or the mole fraction of solute in the liquid. Okay, sometimes there is HI divide multiply with the concentration, but mostly we use this one. Okay, so that means if for any type of pair of components between the solute and also the absorbent, if you have the data of Henry's law, you can also make a plot between a Pi and also the Xi. Okay, so this one is your equilibrium data. Okay, and as I said before, the absorption is carried out in tri-column and also pack column, but for our learning purposes, we're gonna use the pack column, yeah, for the absorption. So then for what we're gonna discuss now is the pack column. All right, up to here, I'm just gonna stop it first, and then if you have any questions about the concept of absorption, please. Any question? Are you still who is in Bandung? No? Or everyone still outside Bandung?
I'm in Bandung, Bu.
Oh, Gamma in Bandung. Dia also. Gamma and Dia, are you ngekos or is it your home?
Okay, Gam.
Oh no, I'm at home.
Oh, Gamma is at, so okay. So where do you live, Gamma?
I live in Cibaduyut, ma'am.
Okay. How about you, Ilham? Do you have a
I live
course?
at a course, yeah.
All right. Dia, where do you live?
In Jalan Merdeka, in front of BIP.
Okay, on the apartment, yeah.
Yes, Bu.
Okay. Did you went there because you have to go to the a good high school in Bandung? No.
Yes.
Yeah. SMA 3.
No, SMA Santa Angela. Tinggal jalan
All
kaki.
right. Okay. Yeah. Because at the moment now, if you want to have a to be a good high school, then you have to live near over there. Yeah. Okay. Anyway, why I talk about this because yesterday I went to the campus and then I saw my office after 1.5 year, and then I don't know. Hopefully, yeah. If can you go to campus or not from the Kaprodi or not yet, yeah? Or it hasn't been any requirement or rules to start, yeah, but anyway, but we really want but looking at the ITB, yeah, and also I checked to my office because in these 1.5 years I work at Satuan Penjaminan Mutu, ya, Quality Assurance Unit, so I mostly go to here in Cikapayang, but not to ITB. And yesterday I went to ITB and to see my campus. So, we can make more academic learning, yeah, in ITB, and hopefully if the pandemic can be decreased again, or we apply those new normal things. I hope you still can have experience to work as a group, yeah. So don't because working as a group in Zoom is not the good thing, yeah. So you can maybe ask who is your maybe the smarter person in your class to write something, okay. So you can listen the lecturer, check the write on the whiteboard or something, and then I think that should be exciting, yeah. But anyway, so I don't know, maybe you need to wait from your program coordinator, Pak Hardev, where we can start having those academic atmosphere, yeah. Because what is the difference between, for example, if you studying at ITB, for example, or maybe at the university, or maybe abroad, yeah, overseas, yeah. The difference is just the academic atmosphere, yeah. Every university has their unique academic atmosphere, okay. So for example, the one in Japanese and also the one me, for example, I studied in Australia, the academic atmosphere is just so different, yeah. The openness, for example, the work ethics, the study ethics, and so on, okay. So I hope you can enjoy ITB soon, yeah. Just few cents. Anyway, okay. Right. Okay. So now we're gonna talk about the pack column. Okay. But up to here, we just want to stop it. And then, is there any questions? How about others? Who is overseas? Is everyone in Indonesia now, or who is overseas? Still.
Me,
No?
Bu.
Oh, Helena, you still overseas?
Yes, Bu.
So where are you now?
Currently in Qatar.
In Qatar. So what time now?
It's 10:35 now in the
Okay,
morning.
so it's good to be still in the morning, yeah. But so that means if you have a morning lesson, that would be around 4 o'clock maybe, yeah, in the morning, yeah. All right. Okay. Right. Look. Okay. So if there's no questions, then let's move on to the next part. Okay. So let's start again with the packing column unit. Yeah. This is the packing column. The packing column it's like it's like a honeycomb. It's like a honeycomb, or sarang lebah ya, or there's some ideas, because what we want to see is actually how to have a contact between the gas and the liquid. Okay, so if we go back here, the gas should have contact with the liquid, yeah, whatever it takes. Okay, and of course the contact between the gas and the liquid is actually based on the surface. Okay, so the more surface that it has between the liquid and the vapor, then it will have the mass transport. Okay, if we have, for example, like this bottle, of course the contact is only on between the cross section of the area here, the surface, yeah, the interface between the liquid and the vapor. But if have something like we call it packing, the wetted area, luas yang terbasahkan, it can be higher. Okay, so it looks like this. There are two types. It is a structured packing yang terstruktur. Okay, and then usually the column unit also very high, because we got later on we're gonna calculate how to calculate the height of the unit, tinggi column. Okay, and then there is a base in here, and then also we have the this one is the liquid. Okay, the liquid from the top, and this here is there is a distributor, a liquid distributor, and also there's a hold on grid, and then hopefully the distributor, the liquid distributor, will distribute all the liquid to make it like a dripping in everywhere. Okay, from the bottom we have the vapor feed, yeah, the vapor feed, and then of course the natural way of vapor feed, which is gonna vaporize like that. Okay, and to make it spread it again, we have the support plate, and then where is in the support plate there's also a lot of holes where the vapor can pass. Okay, so what we want is we have a distributor of the liquid and also the support plate and the vapor feed as well from the bottom, and they have a good contact together. Okay, but in some cases usually gas likes to travel in the middle, yeah, while the liquid usually want to travel close to the dinding, yeah, to the walls. Okay, so sometimes here we have the redistributor again, so the liquid can be redistributed. Okay, and there are two types of packing. The first one is the structured packing yang terstruktur. So it looks like a honeybee, and then like or like like a honeybee, and then it's just we put it like that as a pack, or like a random packing. It's called rings or saddles. Okay, so this is the type of the distributor from the, this is from the cross-section area from the top view. So you can see for example, it can be like orifice, berlubang-lubang. Okay, or it can be like a wear type, ada apa ya, yeah, like a wear type like that, yeah, like this one little bit, and then you have the distributor, or it can be wear through. So you have some of here, and then it's distributed in those small lines there, right? Okay, so that is the liquid distributor. The next one is the this one is a gas injection support. So from the bottom it looks like this, and in this here is there is a lot of hole. So the gas is distributed directly into the packed bed, and no hydrostatic head. So gas and liquid flow through and separate opening in the plate. So this is the liquid where it passing down, while the vapor around these holes. Okay, so this is it's called gas injection support. So the idea is we distributed all of the gas. Okay, and this is a stack packing yang terpasang, ya, the stack packing disusun for random packing support. And then this is an example of various type of packing on the market. This one is called resting ring. In resting ring you have the wetted area as area terbasahi. this one, yeah, from the outside, and also this one there. But because of the random packing, we just gonna put everything. Of course, we can't menyusun satu-satu, ya. We can't really put it like one by one. So it's just like a small, not very small, yeah. Looks like a macaroni or something, yeah. So maybe a little bit bigger. Make it maybe about 2 centimeters or 3 centimeters. And then, for example, the volume is 2 tons or 3 ton or 5 ton, and then we just pour it out, yeah. For the packing, you just random packing, you just like pour it out, dituangkan, ya, over here. So maybe later there are the one like that one, like the berdiri gitu, or maybe the one that just horizontal like that, or maybe like that, or maybe like that. So just it's just gonna be a difference, okay. So to increase the wetted area, sometimes there are also another one like this. So it's like maybe if you know kue kembang goyang, if you know, yeah, around like that one there. So you have the wetted area on the outside, and also some wetted area on the inside, and then also another one is a rasic ring, or this one is a metal pole ring, and another one there's also a saddle. So hopefully in the saddle, if you put it this way, that way, or another type, there's still around wetted area. So any, and there's also here tripack plastic, yeah, plastic tripack, metal tripack, and then so on. And then so there would be a lot of vendor perusahaan, yeah, that sells a type of packing, and each packing will have some coefficients. Okay, I'm gonna tell you in a minute about, or maybe tomorrow, about the coefficient, okay, because we're gonna use mass transport to check how good is the contact between the liquid and also the gas, okay. The more sophisticated is the packing, maybe it can be more efficient, but sometimes it's gonna result in a higher pressure drop, okay. And so high pressure drop means it should be compensated with maybe more pump power, or other things. Okay, so in summary, usually we can it can be reversible. It can be used for two types of column, okay. So we can use tri-column for absorption, we can use pack column also for absorption, but the difference between tri-column and a pack column is, for the tri-column we have a wide operation, so we can change the reflux rate, we can change the feed, let's say, and then it's gonna maybe affected on the condenser, on the reboiler, right. But for pack column, the operation area is quite narrow, okay. The design for the tri-column is easier, but the pack column is difficult. Why? Because it is more difficult to predict the absorption. It is more difficult to predict the mass transport, okay. Because in equilibrium, there's a lot of data on equilibrium, vapor liquid equilibrium, but not much data on the mass transport for gas and liquid, okay. And even if we don't have the data, then of course it's going to be very difficult, okay. And in tri-column, it is easy to cool and heat the column by adding the for example the condenser, the reboiler, or if in the middle they need to heat it up, to add the heat, we can just put some coil and then add the coil, and then, but for a pack column we can't have that one there, okay. And for side stream, it is easy for the tri-column to get the side stream, but for pack column, it is difficult, yeah, to have the pack column. And then, but however, for the tray column, because it's very big and then large column, if there is one corrosive liquid, it will damage all of the tray, right, from the top, and then the next step, and then the next one. So it's gonna maybe change, expensive to change. But however, for the pack column, if there is a corrosion liquid, maybe the one that is gonna be damaged is just the small packing. Okay, so we can just sort we can take out the packing outside and then check which one is maybe, for example, corroded, and then we just leave it out, or maybe just add maybe new packing, maybe just half a kilo or a few more kilo of packing, because some of the packing are damaged. Okay, and then for the liquid hold up, it is high, but for the pack column is low. It is suitable for foaming liquid for the tray column, while the packing column were not suitable for the foaming one. And then in tray column, the pressure drop is higher because of course it should pass the tray, pass the bubble cap, yeah, while the pressure drop in the pack column is lower, and then is also suitable for vacuum operation. Okay, and then the column diameter is suitable for large diameter compared to the pack column, which is small diameter. So yeah, if you have time and want to try it, yeah, you can. But of course, in the course in this absorption course, we're gonna talk about the pack column. Yeah, just that one there. All right. Okay. Right. Okay. Just one more here. So this actually the principles that we're gonna design in the absorption column is the contact between the gas and the liquid. Let's say this is a packing, yeah, and then this is the liquid is wetting the area around that one there, because the liquid just dripping around the packing, and then the gas of course should flow between them. So then the liquid and the gas it have a contact in this one and also in this one, right? And then the contact here will make mass transport, where the gas will travel from the bulk of the gas to the interface and then dissolve into the liquid. Okay, that it was we're gonna learn tomorrow, I think, about the principle of absorption. Okay, so that means the good packing, we have to find the one that is give the extensive gas liquid contact. It can be should be light as well, jangan terlalu berat, and don't react with the solute, for example. And for some, if the solute is easily corroded, then we can't use the corroded one. And also the packing types, there are random and structured, and for the random one there are from plastic, there are from ceramic, yeah, or from metal. But for the metal is of course it's gonna be easily corroded, yeah, if you have CO2 gas or sulfuric or H2S gas, for example, yeah, or yeah, corroded gas. But sometimes also there's ceramic is good, it's corrosion resistance, but sometimes if we have a high pressure, then the ceramic will contact with each other, and then it's gonna be broken, it's gonna change as well. Okay, so this is an example of ring, and then also type of ring, and then also there's also saddles. All right, so I hope you learn about the type or the basics of absorption, and also we're gonna start again with the column and then with the random packing. And tomorrow we're gonna talk about how to design the absorption column. All right, I'm gonna stop it here. And any questions? Not yet? Okay, then we're just gonna continue tomorrow. The slide is also in the EduNext, so you can have a look and then maybe print it, check it, yeah, check it with you. And then okay, it's okay, also Azan in here. So I need to stop the lesson. Okay, thank you very much everyone for your attention, and then we're gonna see you again tomorrow. Bye.
Thank you, Bu Winnie.
Thank you, Bu.
Thank you, Bu.
Okay, bye bye.
Thank you,
Thank you,
Bu.
Bu.